Good morning, students. So we discussed in a last class so what is ray optics and optical instrument topics. So that is called as a to find out the mirror equation 1 by f is equal 1 by u plus 1 by b. So u is equal object distance, b is equal image distance, f is called as a focal length. Okay. So already we know that in a last class. Today we discuss the another new topic. So that is called as a critical angle. What is the critical angle? Critical angle. So the light ray is passing from denser medium to rarer medium. The light ray is traveling from denser medium to rarer medium. Then angle of incidence for which angle of refraction is 90 degrees in air is called critical angle. Okay, so the light rays is traveling from denser medium to rarer medium. Here taken, so this is called as a rarer medium and denser medium. Okay, rarer medium. So the light ray traveling from denser medium to rarer medium. Okay, so for which the angle of incidence. Okay, so the angle of refraction is 90 degrees. Here taken here 90 degrees. Okay, R is equal 90 degrees in air is called as a critical angle. Okay, got it. So the light ray is traveling from denser medium to rarer medium. Angle of incidence. Then angle of incidence. The refraction is 90 degrees. The refraction is 90 degrees in air is called as a angle of. So that is a critical angle. Okay, got it. Now, so we prove that R is equal, refraction is equal 90 degrees. So then the angle of incidence is called as a critical angle. Okay, got it. Now we prove that what is the total internal reflection? Now, to observe the diagram. So see here. So the object, this is the two mediums are taken. That is the rarer medium and another is called as a denser medium. Okay. సాంద్రత కలిగినటువంటి మీడియం అండ్ విరళం కలిగినటువంటి యానకం. అంటే ఇది వాటర్ అనుకున్నట్లయితే ఇది ఎయిర్ తీసుకుందాం, కన్సిడర్ చేద్దాం. Let's consider the denser medium and rarer medium. So the object is taken in a denser medium. The object is taken denser medium. So the light ray is incident on XY surface on a point is taken A. Okay, is bends away from the normal. You got it? So the light ray is incident on XY surface. XY surface is bent away from the normal. Bent away from the normal. And also the light ray further, so the angle of incidence is increasing. Here taken for example 30 degrees, here taken 40 degrees. So further the angle of incidence is increased, so the refraction is also increases. Got it? So first of all we taken, so consider the light ray in a denser medium. Okay, so the light ray is incident on a XY surface. XY surface. It bends away from the normal. And so further increasing of the light ray angle of incidence. Further increasing of the angle of incidence, and so the refraction is also increasing. Refraction is also increasing. Okay, so for which the angle of refraction, for which the angle of angle of incidence. So the refraction is that is means the ray is not refracted. Okay, not refracted. So the traveling along the XY direction. Okay, so further the angle of incidence increases. So they not a refraction. The light ray is traveling from surface. Light ray is traveling from along the surface. That means so the refraction is taken in air, r is equal 90 degrees, for which the angle is called as a angle of incidence is called as a critical angle. Critical angle. So now further is taken, so another the light ray is increasing of the incident angle greater than critical angle. Greater than critical angle. So the angle of refraction is not the angle of refraction. So the light ray is traveling from into the denser medium, not reflected here. So is traveling from denser medium, okay, or same medium. That means here, so this is called as I is greater than C. That means the critical angle can take equal to the incident angle. So the incident angle is greater than critical angle, for which the angle is called as A. It is not reflected. So the totally it is reflected into the denser medium. So this is called as a total internal reflection. Total internal reflection. Okay, got it. Now here taken, so this phenomena. Okay, so this phenomena is called as a totally internal reflection. Totally internal reflection. So what is the critical angle? What is the total internal reflection? What is the phenomenon? Okay, got it. So now once again see here. So this is called as the object is taken in a denser medium. So this is called as a rarer medium. For example, so this is called as a water and air. The object is placed in a denser medium. The light ray is traveling from, okay, the light ray passes through the incident angle is I, okay, and on a surface, and it bends away from the surface, bend away from the surface. So further the angle of incidence is increasing, the refraction is also increasing. For certain angle of incidence, the not a refraction, so the light ray is traveling from along the XY surface. So that is called as a XY surface. That is called as a, the angle of incidence is called as a critical angle. The angle of incidence is called as a critical angle. Now further the increasing of the incident angle and is complete back into the denser medium or the same medium. So the angle of incidence is greater than critical angle is called as a totally internal reflection. The phenomena is called total internal reflection. Okay, got it. So now take the another topic. So sun appears red. Sunset. Sun appears red. White. Okay, sun appears to red. So now here sun appears red. Why sun appears red? In evening session and morning session. Okay, morning session. So morning session and evening session the sun appears red. Why? అంటే మనకి సూర్యుడు ఎందుకు ఎరుపుగా కనిపిస్తాడు మార్నింగ్ సెషన్ లో ఈవినింగ్ సెషన్ లో. ఓకే, సో హియర్ ద లైట్ రే ఇస్ ట్రావెలింగ్ ఫ్రమ్ అట్మాస్ఫియర్ త్రూ ది అవర్ ఐ. Okay, so the sun light or sun ray is traveling in atmosphere to reach the eye through a long distance in a atmosphere, through long distance in a atmosphere. Okay, so the light ray, so the white light is compound of the or consists of the 7 colors. 7 colors. So that is called as a VGR. VGR colors. Okay, so the light ray or white light is consists of 7 colors. That is called as a violet, indigo, blue, green, red. Okay, so orange, etc. Total is taken 7 colors. Okay, VGR, that is called as a VGR. Okay, so the white is not a color. So white is the component of the 7 colors. So the white color is a mix of the 7 colors. Okay, so the 7 colors is called as a VGR colors. Okay, VGR, YOR, VGR. Okay, VIGBYOR, VGR, 7 colors consistent. So the in evening session, for example, is taken. Okay, in evening session. So the sun is nearly to the horizon. Okay, nearly to the horizon. So the light ray is traveling from atmosphere to reach the eye, our eye. Okay, got it. So the sun to the horizon. So sun is in a evening session. So the sunlight, the sun ray is traveling through the atmosphere to reach our eye. So the atmosphere is consists of the number of the water molecules, dust particles, vapors, okay, so smoking particles, etc. in a atmosphere. So the light, the sunlight is a scattering is through the atmosphere. Okay, the sunlight is scattering through the atmosphere. Okay, so scattering through the atmosphere, so the blue color is more scattering. Blue color is more scattering, and so is escape or through the space. Okay, only our to reach the eye only red color. So the red color is a that is the least scattering. తక్కువగా స్కాటరింగ్ అవుతుంది, పరిక్షేపణం జరుగుతుంది. సో ద మోర్ స్కాటరింగ్ ఆర్ కలర్స్ ఆర్ ఎస్కేప్ ఫ్రమ్ ది స్పేస్. ఓన్లీ అవర్ ఐ టు రీచ్ ది కలర్ ఓన్లీ రెడ్. దట్ మీన్స్ దట్ ఈస్ ద లెస్ స్కాటరింగ్. So the less scattering and also including, so the wavelength is more compared to the other colors. Okay, wavelength is more, so that is lambda. Okay, so the lambda is more. Okay, so the term lambda means wavelength, so wavelength is more compared to the other colors, and scattering value is less compared to the other colors. So because that particular reason, so the sun appears red in evening session and morning session. Okay, so other colors is taken, so the blue, violet, so indigo, remaining other colors are escape from sky. Okay, so because means so here in atmosphere consists of the number of the particles, okay, number of particles and vapors, dust, smoke particles, okay, so that is the scattering through the particles. So scattering up through the particles, so the blue or etc. colors are more scattering is escape from the space, and so only the least scattering is red color. So the red color is reach our eye. Okay, red color reach our eye. Okay, got it. Reach our eye, and so the, also including the wavelength is more compared to the other colors. So because the signals and the railway signals, okay, tower signals, etc., we use the red color because that is called as the wavelength is more. Long distance is traveling. Long distance traveling. That color. Okay, so why? Because the sun appears red in evening session or morning session. Because so the sun is near to the horizon that particular time. On our head, that particular condition, so is taken if the distance is small compared to the horizon. Okay, so and here also the sun appears red in evening session and morning session. Okay, the sun appears red due to the only phenomena, the scattering. Okay, so scattering phenomena. So by using the all particles are okay, all the particles are scattering. So escape from the sky, and only red color is that is scattering is very less and wavelength is more. So that reach our eye. So the sun appears red. Okay. That is a Rayleigh scattering or Rayleigh scattering phenomenon. Okay, because so and very important topic. Got it?